Today's video will be shorter than normal because most of the functions necessary to complete problem set 3 have actually already been covered in previous videos. Now, if you want to see the tutorial for this video or the materials and code for this video, you can always access it as usual on my GitHub page at this link here. Today, I won't be showing it side by side because I just wanted to try a different style of presenting these videos and to give this RStudio a little bit more prominence in the video so you can actually see what I'm doing a little bit better. Please let me know if you like the side-by-side version with this GitHub material, but for today I will just be going like this. So without further ado, we will import the data as usual. In this case, I'm actually importing this receipts.csv file, but as you can see in my workspace, there is no receipts.csv file. And what I'm doing in this function is actually directing the read.csv function to look in the data folder and then putting a slash before the actual file name. And this is the way you can download data without it being in your workspace directly. So you'll see if you go into this data folder, there's receipts and simulations files, but our R file that we're working from right here is actually in this top folder. And so if we were to try to import the data without providing the file name, then we're going to get an error. So just make sure that you have that data there, which is the name of the folder that we're downloading from, and we are able to read our CSV file as usual, and it's in our workspace labeled as df. If we want to check out the first couple lines, again, you can use the head function. And now we will be using dplyr today. Well, it's optional for the students who would like to use it to complete the assignment. As usual, you want to download the package first, which I've already done, and then after you have run this line of code, you need to also use the library function to import those dplyr commands. So I was able to successfully do that. And the first part of the assignment, you need to create a log. And this is actually relatively easy to do. In order to create a new column, there are two different methods you can use. The first method you can use to create a new column into this data frame that we have just imported is to write down the name of the data frame, the new column name that you would like to name it. So this receipts.log here could be named anything. So column name, this is the column name, and then you set it equals to, and you use the log function, and inside the log function you place the data that you would like to take a log of. So in this case, we're going to take the log of receipts. So this is our original data frame. And what you'll notice after we run this code is that we'll have a new column here. So let's run this line of code. And it's blue, so it looks like it worked. But in order to see those changes, we actually need to either click on the data frame itself or use the head function. And what you'll notice is that there's now a new column called receipts log. So we were successfully able to create that new column. And obviously you can create new columns by using other functions too, not just log. You can also divide a column by another column, subtract another column by another column. There's many different ways that you can create new columns. So again, this is a template that you should probably remember in the future because you can use it to extend your original data frame. The other way to create a new column is to use the mutate function. And so you are going to use access the data frame and then put a pipe operator after it. And then we will be using the mutate function as we have before, which creates new columns. And again, we just put the new column name on the left side, followed by an equal sign. And then on the right-hand side, we put the name of the function. and the name of the column that we're trying to manipulate. So if you run this line of code, you'll notice that at the bottom, you also see that we're able to create a log of the receipts. Now, the one thing that happens quite often when people use dplyr is that they forget to actually overwrite the data frame, because when you run this line of code here in 1.2, it actually won't make the changes. It won't save the changes, excuse me. So we have this new column name that displays down here, but if we go into our original data frame, you'll see that there is actually no new column name. So in order to actually see that new column name, what you're going to have to do is type in the name of the data frame in order to overwrite it, followed by an equal sign, and then that same line of code. And what you'll see is that we were able to save the new column name. Now, my recommendation is to actually always keep your original data frame as a reference point and to make copies when possible of any manipulations of different columns that you do. So in this instance, I just created a new data frame called df with log, and that will be a data frame that contains this new log column that we create. And so if I do that, what you'll notice is that we have another data frame here, and then we are able to actually, if for example we didn't make any manipulations to this original data frame, what you'll notice is that you can actually reference the original file. So now we will go on to histograms, which I'm sure you're quite familiar with at this point. I'm just going to show you one point that I haven't showed you yet, and that is how to put the histograms not only side by side, as we will see in this first example, but overlapping as well. For this example, we're going to use an internal data set called mtcars, and so if you just run this line of code called mtcars head, actually it'll show you that this mtcars data set is actually already internally within R, which is really nice for examples. And so in this first example, we will just use the side-by-side histogram as we have before. Again, if you're confused about where this mtcars data set is coming from, you can always save it as mtcars, and that should, so mtcars equals mtcars, and that way you can actually see that data frame has been created up here. And if you wanted to go in and look at it, you can. And this is the data. It's just a bunch of data on cars. And so for this example, in 2.222, sorry, that's quite long, you're just going to see something very familiar, a side-by-side graph as you have before. But we also can overlap histograms as well. And so that's what we're going to do here in number 3. So for this, we're going to actually just import a different data set called simulations. And this simulations data is again in the data folder. So when we import it, we're going to have to put the name of the folder followed by a slash and then the actual name of the file. So we're going to import it as a data frame called sim.df. And we'll just take a look at that that file or that data frame that we've imported, and it looks like it successfully imported. And then in order to create this overlapping histogram, it's actually quite easy. You use the same histogram functions, and you can put, of course, in titles and everything like that as we have done before. But on the second histogram, all you need to do is add this add portion equals true, and if you run both of those together, you'll notice that there's actually an overlap now. So you can compare two different distributions, which is really convenient. So I went a bit quickly through this material, but I think at this point you're quite comfortable with histograms and potentially even creating new columns. So let me know if you have any further questions about the assignment, and please feel free to show up to my office hours on Thursday at 2 p.m. if you would like to go over any of the material. The last thing I will do today, though, is to cover what's called for loops. And this actually relates to the extra credit problem in the assignment. So let me just introduce you to for loops very quickly before I show you the code that is necessary to do the extra credit. You can, in R and other computer science languages, a lot of them have the ability, or most of them, have the ability to allow you to do what's called iteration. And so it just means you can create what's called a loop. And these loops, I can demonstrate for you like a very simple version of a loop. You have a list of numbers, say 1 through 10, and you want to print them out individually. So you can say, instead of I, we can say number in 1 through 10. So that's what this does, is just a list of numbers 1 through 10. Print number. And what that will do is actually print off down here every number 1 through 10. Play around with this. If you put in 5, of course, it's only going to print 5. And the key thing to remember in a for loop is that the right-hand side is where the data is input, and the left-hand side is just the name that you give each individual data. So this, you can name anything. You can put I, you can put number. It's usually good to actually write something close to representing what that data actually is. So in this case, it is a number, and that's why it's easier for me to understand it as writing a number, but it really can be whatever. And you can put anything you really want within the for loops as well. So if I want to say print number and then print I, we will see that it prints my number every single time, and then underneath it actually prints the actual number. We could also combine this. So if we wanted to have that on one line, we could say paste, which is the function to put two different lines together. We could say paste number I, and this will print off, as you can see down here, number followed by I, and I in this case is 1 through 5. So as you can see down here, it printed off number 1, 2, 3, 4, 5. So this is actually really convenient. I'm not going to go too in depth just on this tutorial here, but it's really convenient, and once you start working in R, you'll find yourself using it quite a lot. Kind of a more concrete example that's related to this data work that we've done is to loop over certain information within your data frame. So if you remember, the names function in R gives us the different columns of our data frame. So I'm just creating this object called column names, so we'll run that. And if you wanted to see that, what we just created, just write in col names. You can write it, actually, just let's write it up here just for simplicity. And we can see that it gives us the different names of our columns in the data frame. And if we wanted to actually loop over that, what we would say is for name, or we can say I, we can say X, we can say whatever you want to put in there in column names. So that's the data on the right-hand side. Remember, this is the data. The left-hand side is whatever you want to name it. And you can run this line of code, and what you'll see is that it's actually running one by one, line by line, the different column names. So again, we can put whatever we want within that loop. We can say column is named And then we run that, and what you'll see is it prints off every single time. Column is named, and then followed by the name of the column. So that was quite a lot to take in, but I really suggest that you play around with these for loops and put in your own code. All it takes to create your own for loop is to type for, and then you need those brackets. Again, the name of that you create on the left-hand side, so X this time. In we can create a list. We can create a list of strings. So Monday, Tuesday. I'm just kind of making up an example here to show you. Wednesday. I'm not going to print it all off. And then after that, we will put another bracket, one of these curly brackets. And then now we have a for loop more or less created, and we can put whatever it is that we want within that for loop. For example, print X, which is the name of our data. And what you'll see is that below it comes out Monday, Tuesday, Wednesday. So again, you might think, why is this helpful? Why are you teaching it to me? Well, first of all, we need it to complete the extra credit part of the assignment. And as you go along, you'll also notice that there are many instances where you can use looping because it can save a lot of time. Now, in 4.2, I will show you the loop that will be necessary to complete the extra credit problem. What we're first going to actually do is to create empty lists. So I'm creating two lists called mean5 and mean50. And so what you'll see is that we successfully created that here. If you wanted to see those lists, if you wanted to see what we just did, again, just type in the name of the object and try to print, and what you'll see is that there's actually nothing in the list. What we're going to do in 4.22 is actually put different things within that list using a for loop. So 4.22 here, let's space it out a little bit. This should look familiar at this point. We're using a for loop. In actually this case, we're not going to be printing off the for loop. This for loop is just going to basically run the same code 1,000 times. So for loops are not only good for printing off or reading certain data, it's also good to use to create basically a repeater machine. I don't know if that's the best way to describe it, but just something that runs the code a certain amount of times. And so in this example, what we're actually going to be doing is sampling from the receipts data. We're going to be sampling 5. So I can show you this line of code first. This line of code sample df receipts 5 will just sample 5 different observations from this df receipts data that we have. Again, the df receipts data is here. So it's just randomly plucking out 5 different pieces of data. And what you'll notice is that if you run this a bunch of times, you'll see that the sample is actually different every single time. So it's grabbing different data every single time. And so what we're going to do is take the mean of that sample, and then this mean 5 here will actually place that new data that new sample that we've just created, and it will place it in this list that we created. So it's quite complicated, so I'll go through it one more time. What we're doing is we're drawing a sample of 5 every single time. We're taking the mean. So actually, in the end, we're just creating one number. And that number is the mean of the 5 samples that we've just taken. So if you'll see here, when I run this line of code, we're just creating a mean of the 5 samples every single time. It's just one number. That one number then will be placed into this list that we created. And then we're doing the same thing down here, but with 50 samples. So if you see this, if you take this line of code, we'll take the mean of the sample from the logs, and we'll take 50 samples this time. But what you'll notice is that because we're using the mean function, we are still just getting one number. So the loop will allow us to do this process 1,000 times. So that's what's really nice about the loop, is that it allows us to iterate. So if I, again, just for good measure, we'll go up and create these empty lists in 4.21. You'll see that they've been created over here in our global environment. And then we'll run this line of code that I've provided for you all at once. And it doesn't look like anything happened, but now if you go check back on these lists that we created, mean 5 and mean 50, what you'll notice is that magically they now have a bunch of numbers. So the loop actually worked. Let's check again. Looks like there's a bunch of numbers in there. And so if you want to just see the first 10 numbers or 5 numbers of a list rather than every single one as we did here, you can just type in the name of that data followed by these brackets, C, and then the number that you want to see. So if you wanted to see 5, you would change this to 5. If you want to see 10, you can type 10. And then what you'll see down below is that it only prints out 10. So that's just a little bit easier to read. And then if you wanted to make histograms of that sample data that we just did, you can do that as well. So if you're quite confused about for loops still, I highly recommend you take these examples and create your own examples in order to better understand it. It's quite complicated, so if you don't understand it, don't worry. This is just an extra credit problem. If you want to hear more about it, I can create more examples of loops in the future, but it's not entirely necessary for you to complete your problem sets in this course. It's just a potentially useful command to know if you're doing a lot of data work. But as always, I will be looking for your comments on Perusall, and if you have other comments or questions, please either email me or come to my office hours at 2 p.m. on Thursdays.